Thank you, guys. I can see some great engagement and sharing. If you can get back to the headphones, please. And we're about to start the session now. This will be a level 300 session, and you're in the right room if you would like to know how you can achieve extra cost optimization out of your EC2 fleet, and learn about National Australia Bank's FinOps team Scalable Cost Optimization Initiative. Please join me in welcoming Joshua Samuel, Julian Pittas from AWS, and CK from National Australia Bank.
How many of you have development environments that are possibly left running longer than needed? Yeah, all of you, awesome. Do you feel that you could have more savings but you don't have the data to back you up? National Australia Bank had this challenge, and so today we're going to show you what they've built and how you can actually also do this yourself with our newly open source tool. In our session, we're going to cover the overall problem statement that National Australia Bank faced, what they'd done before leading up to this point, and then we're going to show how the problem was solved, what the technical challenges were, and then finally we're going to show what the results were and how you too can implement this. I'm Joshua Samuel, a solutions architect from AWS, and I've been working with National Australia Bank for the last few years. And I helped solve their toughest challenges. And this was a good challenge to solve, this one. This was one where they came to us with the problem of speed and scale. Their engineering teams wanted to innovate, and they want to move fast. They want to be cautious with when they shut down their environments and not cut themselves off accidentally with their tag-based shutdowns. So teams need to innovate, and a FinOps team needs to make sure that they're innovating in a cost-optimal manner. And it's got to be a partnership. So when this feedback loop happened, this is where we came in to help. When we've been working with NAB on keeping things optimal, we work across all four pillars of cost optimization. We've got see, save, plan, and run. And we need to keep all of these in balance for you to have a good cost optimization over time. So here, we're actually adding to the C pillar so that you can then run more effectively. So, please welcome CK from National Australia Bank up onto the stage, and he's going to talk about the background of how things started.
Thanks, Josh. Hi, everyone. Good afternoon. My name is Chaitanya Krant. I'm Senior Principal Engineer at NAB. What I do? I manage Central FinOps team. My team is responsible for cloud cost management. Today, I'm excited. I'm excited to walk you through NAB's journey, FinOps journey, how we have built strong culture, delivered some real results, and kept improving. I hope this session will give you some great ideas that you can take back to your own organizations. For us, cloud optimization is not just about cutting costs. It is about making our business more agile and scalable. At NAB, FinOps is not just a responsibility of one central team or a central function. It is a shared accountability model. Everyone can see their cloud spend and associated cost, and we encourage them to take action. We focus on data-driven decision making, improving efficiency levels, cloud resource efficiency levels, and we always look for ways to get better and innovate. A key part of our strategy is our chargeback model, providing teams insights into their cloud usage and spend so that they take ownership and find ways to optimize their cloud resources and environments. We adopted Graviton for better price performance. We use Spot wherever possible in our non-production environments for non-critical workloads. What about saving plans and RIs? We have implemented them to get better prices for our compute workloads. We have improved our planning, including budgeting, forecasting, and cost estimation capabilities, so that our teams plan ahead, stay in control to avoid unnecessary cost. Collaboration is a key in our journey. We have built strong partnerships with engineering, product, and finance teams. And we have built strong governance frameworks and tools to drive results. As a result, today, FinOps function at NAB has evolved from a reporting function to a central unit which actually helps our teams in decision making and to run their environments efficiently on the cloud. Today, I will introduce you to one of our key optimization strategies that worked for us. It is called Power Management Platform, the solution that starts and stops applications in our environments based on preset schedules automatically. As I said, it worked, but it has got some drawbacks, limitations. One, it relied on preset schedules which rarely matched our usage patterns. And two, it is based on assumptions. With NAP teams working from different global locations and time zones, we always knew that we need to improve this solution. We need to make it more dynamic, more responsive to meet our requirements. To build such platform, which is data-driven and dynamic to adjust the application schedules, we have collaborated with the AWS team. And as part of this journey, we looked at CPU and memory metrics to see whether this data set can help us to understand the application usage in our environments. But it didn't really work in our case. It failed to give us a complete picture of application usage. So we shifted analyzing network activity log from VPC flow logs and CloudTrail, and it worked. This data set clearly gave us the picture of our usage. When our environments are active, when are they not active? Based on these insights, we shifted from static scheduling to dynamic, data-driven approach to optimize our environments. This approach is what we call the intelligent power management. Before I share more details about adoption and results, let's hear from Julian about the architecture of this platform.
Thanks, CK. So, hi everybody, my name is Julian. I am the solution builder that was brought in to help NAB on this journey. So, like any program that we start, we want to start with a well-defined scope and know what it is that we're actually trying to build. So we found out in this solution that NAB already has a system that can automate the turning on and off of instances, so we didn't need to touch anything there. But what they really needed was the data to understand when they should turn these instances off and on. Every application that's deployed inside of NAB has a application ID applied to every single one of their resources. And when we're generating these reports, we need to make sure that it's rolled up to the application level. And the final piece of scope was it has to be passive. They've already got applications running in their accounts, and we didn't want to introduce anything that would disrupt those applications. We also didn't want to introduce anything that would increase their operational responsibilities when they're deploying new applications. So once we had the scope out the way, we could start addressing the challenge. So the first challenge was, what data do we have available that can help us identify actual usage? And here we investigated a number of different logs. We looked at CloudWatch logs, CloudWatch metrics, CloudTrail logs, ALB logs, but the only logs that actually showed us an increase in usage were VPC flow logs. VPC flow logs record traffic between two elastic network interfaces inside a VPC. So when one instance makes a request to another, this will create a record. And inside this record, we can see the IP addresses of the system that sent the request and the one that was receiving it, as well as the timestamp of when that actually occurred. Now, NAB have a number of different accounts for applications, and we wanted to have a central management account where we would run this prototype. So for every single application account, we needed to go in and enable VPC flow logs. These flow logs then need to be sent back to the management account, and we were able to do this with Amazon Data Firehose. Once we accept all these logs, we can transform them, and we can store them in an S3 log bucket for processing later on. So the next challenge that we faced was, how are we going to group these applications? Because these logs are at the resource level, and we need to roll them up to an application level. The way that we achieved this was using CloudTrail logs. CloudTrail logs records every action that happens on the control plane, and it allows you to filter for the exact records that you're interested in. So in our application, we were only interested when an EC2 instance was created, and when an EC2 instance was attached to a load balancer, because this would change the IP address, which we could then associate with an application. Every instance had that application tag on it, so we could trace it back between the IP address and the actual application it belonged to. And we would grab all these records and build an IP map, which would give us from the account number, the region, the VPC ID, the IP address, and what application was associated with that IP address. Now that was fantastic for anything that was newly created, but they already had a number of application accounts that were running applications. So to solve for this issue, we had a script that would run at the very start of the prototype, and it would go into every single application account, and it would take an inventory. What are the instances? What are their types? What are their IP addresses? What are the ELBs that they're attached to? So we can actually attribute the traffic from the start of this prototype. For anything that was new, we would then use that CloudTrail log data, and we would store all of this in a log bucket so we can transform it later on. So now we have the applications and the IP addresses that they're associated with, and we have the traffic. So we need to map those two together to actually get usage. The way that we did this was just using a single Lambda function, and it was on a schedule. We would run this every hour. That Lambda function would go get the initial snapshot from the S3 bucket, so that way we had the IP map from the start of the application. And then we would use Amazon Athena, which is a NoSQL service that allows us to query logs in S3, to pull out all of the instances and application data since the start of the program to now. We would then grab all of the VPC logs between a predefined time period, and for each of those VPC logs, we would look at the IP address and we would associate it with that IP map table that we created, which will give us the application, which we then added to those logs. So we enhanced the logs with more information. Once we processed these records, we were able to save them back into S3, so we could display them to the user, as well as do some further processing. And this was the final challenge that we had of the application. Once we've got the usage logs, how do we actually translate that to savings? Now, we did this for every application, but just on the screen, I'm just going to highlight how we did it for a single application. So for a single application, we would look at a single day, let's just say a Monday, and we would query for all the logs of that specific Monday and order them by time. We would then go down and we would see from the record that we're currently at, how long since the previous record, and if it met our predefined time frame, which I think we set to an hour, then we could say that was a time of inactivity, and we would see how long that was actually occurring for. We'd then do this over the whole week, just to say that this was a pattern that we were seeing in the usage for that particular application. And then we could pull out time frames of inactivity for that application. Now, since we have that IP address map and we know what EC2 instances are associated with an application, we can actually figure out using the pricing API, how much does it cost per second per application. And with that time data and that pricing data and the times of inactivity here, we could calculate how much savings you can achieve if you apply these rules. Now, the architecture for this is a little bit simpler. It was just done in a single Lambda function, and we would run this once a day. These reports didn't need to be instantaneous because they were just checking them every day. We would use Amazon Athena again to query the application for a specific time period. So in this instance, it was over the past 7 days. We would do that processing, and then we would save it back to an S3 bucket to display to the user. So the final piece of the puzzle was, how are we going to actually enable the team to use this tool so they can have conversations with the team? For that, we set up a web application. So we stored the static website content in an S3 bucket, and we hosted it with a CloudFront distribution. We used Amazon Cognito for authentication, so they could switch credentials and get a token. And then they could use that token to query to make a request to the API gateway. And we had two main endpoints for this application. There was the analytics endpoint, which would show you the actual metrics for a particular application, or the recommendations endpoint, which would pull out that last calculation of what are the time periods that you're saving, as well as how much are you saving. So this was the final prototype that we produced, and this is showing the recommendations page. So at the very top, it'll tell you how many applications are loaded into this program and how many of those applications have recommendations that you can apply. On the very right, it would show you, if you applied all these recommendations, how much can you save? Further down, we break it down by application level. So these are the applications that have recommendations on them, and for each of them, if you apply all the rules, how much can you expect to save? If you click on one of these applications and you want to see the actual information, this will show you the recommendations for that particular application, as well as the time periods of inactivity and how much you can save if you apply it just for that specific time period of inactivity. Now, this was fantastic as a high-level overview for the team to say, hey, we can actually save costs here. But when you're talking to a team that you're going to and saying, hey, we're going to shut down your instances, you really need to have the data to show them why and when you're actually going to do it. And that was exactly what the analytics page did. So here, over a specific time period that they could filter, they could show the team when their instances weren't actually being used. And once they got agreements, they could then create a schedule to turn off that instance when it wasn't in use. So I'm going to hand back now to CK, and he's going to go through what happened post-prototype after we hand it over. Thank you.
Thanks, Julian. And these patterns definitely match our usage. Now let's talk about the adoption at NAB. Once the prototype was made available to us, we wanted to start small. So we piloted it with a few teams. Our goal was simple. We want to validate the solution and gather feedback from real users. During this phase, we have received some serious feedback from our application teams. They had concerns about the availability of applications due to the dynamic nature of tagging. That's a valid concern. And they needed more support and guidance from my team. To address these issues, these concerns, we have provided targeted training, created clear documentation for them, and offered hands-on support so that they become confident about the platform. So, and based on this feedback, we have refined the solution. This initial engagement had a very big impact, and the feedback what we received was invaluable to us. As I said, this feedback helped us to refine the solution and plan for broader rollout across NAB. Today, this platform supports close to 500 applications and is deployed across 2,000 plus odd non-production environments. But the point is, this change is not just limited to technology. We have improved our processes. Power management is now part of our standard operating procedures. It is no longer an optional task. It is part of our engineering day-to-day practice. We expect every engineer to look at the recommendations suggested by this platform and apply changes to their environments. Now let's talk about the numbers, results. This work has resulted in strong measurable impact. One of the key outcomes is the significant cost savings that we have achieved through dynamic tagging of non-production environments. But the impact of this solution goes well beyond just cost savings. It has fundamentally changed how our teams manage their environments by providing insights into actual usage and by dynamically adjusting the application uptime. So this is not a one-time win in our case. It is a continuous improvement process. To keep the momentum going, today we provide regular recommendations to our teams, and we track tag adoption and savings in real time so that we understand what is working, what is not working, and where we need to focus for further optimization. Looking ahead, we plan to improve this solution. We want to leverage ML, AI to make it more dynamic, smarter, to drive long-term results. We also want to automate the process, the complete process from tag creation to tag implementation to make our operations simpler and scalable. So all in all, this solution, this innovative solution, intelligent power management, not only helped us to save numbers, improved efficiency, but also helped our teams to manage the environments efficiently. Thank you. Josh, what's next? Where can people start their power management journey?
So see how much you can save by scanning the QR code at the top here. Get your phones out and scan it. This is our open source repository that we released last week, and it can generate recommendations in your account. Put a star on your GitHub, on the GitHub repo, so you remember it when you get back to your office, and try it out. As you saw, it's a low risk thing that you can try. You don't need to install anything on all of the accounts out there, no agents or anything like that. It's designed to show you where you can apply your savings. It might show you that you need tag-based scheduling, in which case the AWS Instance Scheduler is one solution that you can try, and there's others out there that can shut things down based on tags. Or it might show you that you've got development environments that just aren't being used. You had a project, you had 20 projects, and you just left them running and people forgot. Okay, that's another thing that you might see here. So depending upon what the report shows, might change your next steps, but give it a try. We're going to be over at the Q Developer area back there in the developer lounge over the next half an hour to an hour if people want to ask us follow-up questions, find out a bit more about how you can try it out and the like. And please fill out the survey. We always like feedback. So thank you, everyone.